Hello, in this session we will be starting with module 2 in which we are dealing theodolite traversing. So we know that we can classify survey as triangulation survey and traverse survey based upon the principle which is employed in doing that survey. So this traverse survey can be considered as developing a framework of survey lines which are actually connected together. So we will be traversing or we will be moving from one station to another station with the instrument. And if you can join these instrument stations in sequence, then we will be getting a framework of lines. And that kind of framework over which we can develop all other details is called the traverse work. So these survey lines have to be, which are connected together, have to be properly understood, and they can be understood by means of their direction as well as length. So in this survey framework, we can define each and every survey line by means of its direction and length. Direction of survey line will be measured in terms of angles, and we can make use of the instrument theodolite for measuring the angle accurately. Length of the survey line we can measure either by using a tape or a chain. So there are two kinds of traverse we can do. One is called open traverse and the other is called a closed traverse. If the framework of lines which we are developing do not come to a common point, for example, we start the survey work by setting the instrument at one location and we end the survey work at another location which do not meet with the first one, then it can be called an open traverse. So this kind of traverse we usually have to do for surveying road, canal, railway line, pipeline, tunnel, etc., where we can see that the predominant feature is the length. So for any linear feature, we usually go for open traverse. We start at one end of the feature and we continue and we may be ending at another side of that feature. We never come back to the original location. So that is called an open traverse. Now let us see what is a closed traverse. In a closed traverse, we will be starting our work by setting up the instrument at one location and we will be moving on to another location like that, and finally we will be coming back to our original location. So survey line ends at the starting point and that makes a closed circuit. Such kind of traverse is called a closed traverse. So whenever we want to measure an area of wood or an area bounded or occupied by a pond, an area for a compound, so any enclosed entity can be surveyed with the help of traverse, closed traverse. So we will be coming back, we will be able to move around that entity and come back to the original position. So now we are going to learn what are the different methods of traversing. So traversing can be done either by measuring angles between these successive lines or by measuring the bearings of every line. These are the two methods of traversing. Either you will be measuring directly the angle between consecutive lines of survey lines, or we can measure the bearings of each and every survey line and then plot. So these are the 2 basic ways of doing traversing. So now we are going to learn what are the different methods of traversing. So traversing can be done either by measuring angles between these successive lines or by measuring the bearings of every line. These are the two basic ways of doing traversing. So these are the 2 basic ways of doing traversing. So So the features of these two methods can be explained like this. If you are measuring angles and especially using a theodolite, that method is more precise. So whenever you are going for a long scale work, large scale work, a long traverse is required. In that case, we want to minimize the error, then we have to go for angle method of traversing. The direct observation of bearing method can be used for topographical surveys and whenever accuracy demanded is less. So let us see how to do traversing using angle method. So here there are two options for doing this by this method. First option is you can get the included angles between successive survey lines. Here you can see there is one survey line, then later another survey line. We measure the angle between these two. Then the third survey line, you can measure the angle between second and third. Another survey line, you can measure between third and fourth survey lines. So in this way, between each and every survey line, we can measure the included angle. So even though we are doing the traverse with the angle method, we need to know how the orientation of the entire feature is. For that, we need to get a bearing of any of the survey line. So we have to take at least one bearing, and that can be taken either at the starting or you can take it at any other location, any other instrument station. You can have a compass with you and note the bearing of any of the survey line along with other included angles. The angle can be deflection angle. So here also you have first survey line. Then you are going to measure how much is the second survey line deflected from the first one. So the prolongation of the first survey line can be found here, and from that prolongated line, what is the angle to the next second survey line? So that is called a deflection angle. How much is the deviation of the survey line from the preceding line? So that can be measured, then it can be called a deflection angle method. Here also you have to take the bearing of at least one survey line. So let us study this in detail. So direct observation of angle, and there are two options. One was using included angle, another was deflection angle. Let us see how to do with included angle. So what is included angle? It is the angle made by two survey lines at a station. So how to do that? We will be always at a station, we will be always referring back to the previous station. That will be our reference, and from there to the succeeding station we will be measuring the angle. If you want to increase the accuracy, here you can go for repetition method. We are going to measure the angle between two lines, and that can be made accurate by doing it repeatedly. So repetition method can be employed. And these angles can be measured either it will be in the clockwise direction or it can be in the anti-clockwise direction, and it depends upon in which direction you are moving around that object or that entity. For example, here you can see we have a plot bounded by PQRS. We want to conduct a traverse survey and we have selected the station points at PQRS. So as a first step, we have set our instrument at P, and as we have to take one bearing, we have taken the bearing of line PQ. Then we move to Q. Instrument is shifted to Q. Then we will be sighting to R, and before that we will be back sighting to P, and from there we take the angle to point R. So you get this angle. Then we'll be moving on to shifting the instrument to R. Orient your instrument to the back point Q. Then you start measuring the angle to S. Then you will be getting this angle. Similarly, you will be getting angle at S. Right. So all these angles which you have actually measured are exterior angles, because you have measured, you have moved around your feature, around your plot in the clockwise direction. So whenever you are following this sequence P, Q, R, S in the clockwise feature, you will be getting exterior angles. So then you will have to take at least one bearing as usual. Okay, let us suppose we are moving in the reverse direction. We started by setting the instrument at P, then we took the bearing to S, then we shifted the instrument to station S. So here we are moving in the reverse direction, anti-clockwise direction. Then again at station S, we will be backsighting to P and then taking the angle to R. So you will be getting the included angle between PSP and SR. So this can be continued like that. At station R, you will be again getting the included angle. This happens because the instrument theodolite is having the graduations in the horizontal circle from 0 to 360 degree in the clockwise direction. That is why you are having this kind of measurements. So here you can say if you are moving in the anti-clockwise direction, you can get the interior included angle between the survey lines. Now let us move to the next method. Again, observing the angle. Here we are going to observe the deflection angle. So what is deflection angle? It is the angle made by a survey line with the prolongation of the preceding line. So it can be the measurement can be either towards left or right, or we can say it can be clockwise or anti-clockwise. So if it is towards left or right, we have to specifically mention to which direction the deflection angle is measured. So usually this kind of method, deflection angle method, is adopted for open traverse, like when we are doing the traverse survey for road, rail. So with this we are going to stop this part of theodolite traversing. Thank you. Theodolite traversing can also be done by direct observation of bearings. So such kind of method can be called fast needle method. So in this method we are actually measuring the bearings of each and every survey line in the traverse. So there are different ways by which we can take the bearings of lines, and the three methods are direct method in which telescope can be transited, direct method in which telescope cannot be transited, and back bearing method. It can be adopted when you are provided with a transit telescope, which can be transit theodolite, which can be rotated in the vertical plane. But we have to ensure that your telescope or your instrument is in perfect permanent adjustment. The second method can be adopted when you don't have a transit theodolite, or you have a transit theodolite but with a poor permanent adjustment. Third method is also another method in which you can get the bearing by back bearing method. So let us go through each and every one of these methods. That is, if you are provided with a transit theodolite which is having a good permanent adjustment. So we need to do a traverse survey to measure the plot A, B, C, D, E. So A, B, C, D and E are the stations in which we are going to set up our theodolite. So I have set the theodolite in the station A and have done all the permanent temporary adjustments at the station A. Then I have set the vernier A of the theodolite to read 0 degree. Now, as we need to have the bearing, we have a compass along with us, and I have oriented the telescope of the instrument towards the magnetic north. That is done with the help of loosening the lower clamping screw. Now, we want to get the bearing of the line B, AB. So we have the line, let us continue from A to B. So we have the line AB and its bearing. Now I have shifted my theodolite to next station B. Then I have set up or done all the temporary adjustments at B, but I am ensuring whether the reading on the vernier A remains the same or not. I am not loosening the upper screw, upper clamp is tightened even if I shifted from A to B. So the reading remains the same. I am loosening the lower clamp and backsighting, turning the telescope to backsight point A. So what is the situation now? Our instrument is sighting point A, but still the reading remains as the previous reading. Now I am transiting the instrument, because transiting is the process in which we can rotate the telescope in the vertical plane. Our telescope is now looking exactly opposite to the direction B2A, right? So now the telescope is oriented towards the direction AB in its extended way. But the reading still remains the previous one. So I will be now losing and turning or rotating the theodolite till you see the point C. So what will be the angle that you will be getting in the vernier A? Initially you are having the same reading as the reading of line AB or bearing of line AB. So this is our north, and this angle remains like the bearing of line AB. Now you have turned the telescope by loosening the upper clamp through some angle, say theta degree, theta 2. So initially you had a theta 1, now you have theta 1, theta 2. So altogether theta 1 plus theta 2 will be the reading which is being shown in vernier A. So that is nothing but the angle of line BC from the north direction. That means it is nothing but the bearing of line BC. So what we are getting is directly the bearing of line BC. So this is the process in which we have used a transitable theodolite. Let us do one more step. I have shifted the instrument to C, but at that time my vernier screw is clamped. So whatever reading which was there, that was the bearing of line BC, that reading remains there intact. Now I have set up the instrument at C, done all temporary adjustments, and I am backsighting to point B by loosening the lower clamp. Then what I have to do? I have to try. So your instrument will be looking in the direction from B to C and to its extended way. But the reading still remains the bearing of line BC. So next, the reading whatever you are getting still remains the same. Now I have turned the telescope by loosening the upper clamp so that the vernier reading gets changed, and I turned it till point D is sighted. So what is the reading that you are getting in the vernier ray? That will be actually the bearing of line C to D from north. It is the angle actually from the north. So it is the bearing of line CD. So this is the process in which you will be getting the bearings of each and every line in the survey framework. So it is called a direct observation of bearing using a transitable theodolite. Now let us think of second case in which if you don't have a transit theodolite, or if you feel that the permanent adjustment of theodolite is not perfect. So if you are transiting it, it will give you an erroneous direction. In those two cases, we can adopt second method. So it is applicable for non-transit theodolite and for instruments with a poor adjustment. Steps are again similar to the previous case. Set it up at P, and that vernier screw remains the same, and I have unclamped the lower screw and sighted to the point A. So I have actually back sighted to point A. Now here we don't have the option to transit the theodolite because theodolite is a non-transitable instrument now. So in this case, what we have to do, we have to, in order to sight to C, we have to rotate in the horizontal plane only. So what I have turned the telescope after unclamping the upper screw or vernier screw till I see the point C. So here you have actually covered some distance which is extra. So you have moved some 180 degree in addition. So what you have to do? Now the angle to C will be having 180 degree difference with the previous reading. As the instrument is unnecessarily, we have to rotate through 180 degree to move to the next point. We have to do some correction to this unnecessary movement. So apply a correction of 180 degree to the reading at verniers. So if how to do that correction? If you are having a reading which is more than 180 degree, you have to subtract 180 degree from that reading. If your reading when you are observing C is less than 180 degree, you have to add 180 degree to your reading. That will give you the bearing of line C. Now let us move. That upper clamp remain intact, back sighted to point B. Now I want to continue the surveying process by looking to next point D, but there is no way to transit instrument. So I have to unclamp the upper screw. So this entire circle we have completed. So here also I am actually moving the instrument through 180 degree. So we have actually turned the instrument unnecessarily 180 degree twice. One is at B, point B, and another is at point C. So altogether, from this beginning, we can say that almost 360 degree was actually, if one full round was actually completed to site D. So 360 degree is nothing but 0 degree. So here we can say that as the orientation becomes up by 360 degree, we need not have to do any correction. So whatever reading you are getting from the third instrument station will be exactly the bearing of line of CD. Which we have to do. Continue. So we can say that in this method, the 180 degree correction need to be applied only at even number of instrument station. That is, we have to do the correction 180 degree correction at the second instrument station, fourth station, sixth station, etc. We need not have to do any correction to the readings we have taken from first station, third station, fifth station, etc. So this is how we have to do the traverse if you are having a non-transit instrument. To the third method, it is called the back bearing method. So in this method, we are setting up the instrument at the starting point A, and we will be observing the bearing of line AB, just very similar to the previous cases. So we have set the instrument at A, made the vernier A reading to 0 degree. After loosening the lower clamp, directed the telescope to magnetic north direction, then tighten the lower clamp. Then we have to loose the upper clamp or vernier screw and turn till we sight point B, next point B. The reading in vernier A and B, that value will give you for bearing of line AB. Then we have shifted the instrument to next station point B and set it there. Then what we are doing is, we know that already some angle, say theta, was the forebearing of line AB. If theta is the bearing of line AB, then what about the back bearing of line AB? That will be having a difference of 180 degree. That is the basic principle when we have learned the compass survey. Forebearing and back bearing of the line will be having a difference of 180 degree. Suppose theta is the angle or forebearing of line AB, then back bearing of line AB will be having 180 plus or minus theta. So you can calculate what is the back bearing, what have to be the back bearing of the line AB. So once we set the instrument at the second station point B, you can unclamp the vernier screw and set the angle as 180 plus theta or 180 minus theta, as the case may be, which is the back bearing of the line AB. So we are deliberately setting the back bearing reading. Once we have set it, we can clamp the upper screw or vernier screw. By operating the lower screw, we can direct the telescope to backside point A. So with the vernier A kept clamped backside to A by using the lower clamping screw and its tangential screw. So what happens now? As the vernier is set to the back bearing of line AB and the line of sight is now directed to B to A, the instrument is in correct orientation. So now we can continue to take the bearing of line C. You can unclamp the upper plate and turn the telescope until the point C is sighted and exactly bisected. Again, note down the reading at vernier A and B, and that angle will give you the bearing of BC. Suppose you got that angle, then you can say that if bearing of line BC is obtained, you can calculate what should be the bearing of line C to B. Or in other words, we can calculate what is the back bearing of line BC by adjusting with the 180 degree. So you may be shifting your instrument to C, and in vernier A, you make the angle to that particular back bearing angle. And keeping that angle in your vernier, you can direct the instrument to backside point B. This is from station C. So now the orientation is again correct. So here we are back orienting the instrument with the back bearing method. So this process can be repeated till you complete all the stations. This is called the method of back bearing. So we have learned what are the different methods for doing theodolite traverse. You can go for angle method or bearing method. In angle method, you can go for included angle method or deflection angle method. Then in bearing method, you can either go for bearing with a transitable theodolite, bearing with a non-transit theodolite, or bearing with back bearing method. So with this, thank you.